Trigonometric application. A consumer notes the sinusoidal nature of her monthly power bills. In winter, when she uses electricity to heat her home, and in summer, when she cools her home, the bills are high. In spring and fall, significantly less electricity is used and bills are much smaller. The following function models the behavior. C of t equals 60 plus 40 times cosine of the quantity pi over 3t minus pi over 3. Here, C of t is the cost of power bills in dollars for the month t, and t has to be less than or equal to 12, but greater than or equal to 1, and t equals 1 corresponds to January. So for what values of t, where t again is between 1 and 12, is the cost exactly $80? So here they're giving us a function and asking us a question, and so what the process is going to be is setting up an equation and solving it to answer this equation, this question. So how we can do that is first look at this function. So I know this function just represents a set of ordered pairs of inputs and outputs. So I want to think about what my units are going to look like. So the input units I know is just time, and it really represents this is just time in months. So this is time in months. And then the output is just dollars, right? So, okay, so just dollars. Great. So this is saying for what values of t is the cost exactly $80? Okay. So for what values of t is the cost exactly $80? So if they're giving us a cost, I'm going to use that to replace this entire left side of the equation, and then solve the equation for t, because they're saying for what values of t, that must mean I'm solving for t. So I set up this equation, replace C of t with 80 representing $80, and then everything else is just left the same. And then I just go ahead and solve this equation. So first I need to try to isolate my cosine. So before that, I need to try to solve. So subtract 60, I get 20 equals 40 cosine pi over 3t minus pi over 3. Divide 40 on both sides, I get 1/2 equals cosine of pi over 3t minus pi over 3. So something that we can do here now is use substitution. So I'm going to say let u equal this big thing, pi over 3t minus pi over 3. And so when I do that, that also changes my boundaries. So it was from 1 to 12, but let's plug in 1. So if I plug in 1 for starting of my boundary, I get pi over 3 times 1 minus pi over 3 is 0. And then if I plug in 12, which is the end, I get pi over 3 times 12 minus pi over 3. This gives me 4 pi minus pi over 3, which is just 11 pi over 3s, right? Because this is just 12 pi over 3. Okay, so I'm going to rewrite my equation knowing the substitution that I just did. So now my equation is 1/2 cosine of, 1/2 equals cosine of u. And then the interval, so on what interval? Well, the interval starts at 0 and ends at 11 pi over 3. Okay. So then what I'm going to do is solve this equation. And so what I first usually do is just use the unit circle to kind of start from there. So where is the cosine of u equal to 1/2? Well, that happens at pi over 3 and again at 5 pi over 3. Okay. So I'm going to start out and say, well, let's let u be, or sorry, I should just say u is pi over 3, or let me just put a comma, it's a little bit saving time here, space, 5 pi over 3. Now, when I have that, I'm really asking, do I have any more in here? Because I notice that the maximum I can be is 11 pi over 3, and I'm a little ways away from that with my last two, so it's always a good idea to check. So I just start checking coterminal angles. I say, well, what if I added 2 pi to here? So if I added 2 pi, I would get 7 pi over 3. Would that work? Yeah, it would still be less than that 11 pi over 3. So I'm going to say u can be 7 pi over 3. Okay, now I'm going to try adding 6 pi over 3, because again, that's just 2 pi. And I get 11 pi over 3. Does that work? Yes, exactly. And I look up and I say, less than or equal to 12. So that's why it's less than or equal to 11 pi over 3. So that upper bound is actually inclusive. So u equals 11 pi over 3 will work as well. Okay, so I'll erase this just to kind of say I found it. Now, is there going to be another one? No, I already reached my max. Is there one below pi over 3? Like, could I sneak one in there? Well, I could try, but my first one, like, what would that be? It would be going negative down to here, right? It would be negative pi over 3, but that's not going to work because I would be below 0. Okay, so now that I have those in terms of u, I'm just going to go back and replace them in terms of my, let's see what I had, t. So I said let u be pi over 3t minus pi over 3. So now my job is just to replace it back. So I have pi over 3t minus pi over 3, and that is equal to pi over 3. One thing that's going to make our life a little bit easier here is to just divide pi over 3 from each term. What would happen if I did that? Well, this would be t minus 1 equals 1, and so t equals 2. So again, I just divided out pi over 3 from each term. I can do the same thing over here. Pi over 3, t minus pi over 3 is 5 pi over 3. If I divide out pi over 3 from each term, I get t minus 1 equals 5. So t equals 6. Do it again. Pi over 3, t minus pi over 3 equals 7 pi over 3. I get t minus 1 is 7, so t is 8. And then over here I get pi over 3, t minus pi over 3 equals 11 pi over 3. T minus 1 equals 11, so t equals 12. Okay, so I have 2, 6, 8, and 12 for my answers. And then when I'm writing this in a sentence, I want to go back and look at like what she's saying for what values of this question is for what values of t. And so I can answer in terms of t here, right? I could say, well, these are the t values. I could put in a solution set 2, 6, 8, 12. But they also give us information about t corresponding to months out of the year. And and this is asking when's the cost exactly $80. So the cost of the power bill is exactly $80 during, all right, so what do we have here? 2 is February, 6 is going to be June, 8 is August, and 12 is December. So for a question like this, they're going to, give us some function. We're replacing here the output value, okay, with the 80, solving an equation. Here we needed some substitution because the inside was not just a plain t, it was a little funky. Here there are actually 4 separate values, so we're able to accommodate that. And then here it is in terms of t, and then writing an answer to an application in a sentence is a good idea, and just bringing it back to like, what are we actually finding here?